Titan, with its hazy atmosphere and massive size, has long captured our imaginations. It's the only moon in our solar system known to possess an atmosphere thicker than Earth, and get this, it's the only other extraterrestrial body known to have liquid on its surface. Titan holds many intriguing secrets that make it an exciting place to explore. From organic molecules to its methane lakes, Titan has piqued the curiosity of scientists around the world, and NASA's Dragonfly mission is poised to provide answers to some of our most profound questions about this moon. Does it hold the building blocks for life? Could life already exist there? In today's video, we showcase all the captivating details about Titan and the Dragonfly mission, a crucial chapter in our quest to understand the mysteries of our cosmic neighborhood. Titan is Saturn's largest moon, and the second largest in our solar system, Jupiter's Ganymede being the first. With a radius of more than 2,500 kilometers, 1,553 miles, the moon is relatively easy to spot. Using a small telescope, just like Dutch mathematician Christian Huygens did in 1655, you can see Titan as a brown dot near Saturn. In 1944, long before any spacecraft was launched into outer space, Dutch-American astronomer Gerard Kuiper discovered that Titan had a thick atmosphere, unlike any other moon in our solar system. By using a spectrograph to analyze the sunlight reflected off Titan, Kuiper observed characteristic absorption lines that indicated the presence of specific molecules in Titan's atmosphere, such as methane and nitrogen. Building on Kuiper's work, scientists sought to discover the reason for the thick clouds and what other strange phenomena might be occurring on the moon. Pioneer 11 and the twin Voyagers took a look at the moon from a distance, and they got details about its temperature, pressure, and of course its dense atmosphere. From this data, scientists speculated that the moon's methane-rich atmosphere and average temperatures, lower than minus 179 degrees Celsius, minus 290 degrees Fahrenheit, might combine to form oceans of liquid methane. Liquid oceans on a moon's surface. Could it be possible? This question would become the driving force behind the Cassini-Huygens mission. Designed by the European Space Agency, the Huygens lander became the first spacecraft to land on a celestial body in the outer solar system. During its 2.5-hour descent through Titan's thick atmosphere in January of 2005, Huygens delivered invaluable information about Titan's chemical makeup, as well as stunning, never-before-seen images. Impressively, the lander, which was never designed to survive the fall, managed to continue returning images for another 1 hour and 10 minutes after landing on the moon's muddy surface. The remarkable photographs revealed a diverse environment, with river channels, dry lake beds, and pebble-like structures, all indicating the presence of liquid on the moon's surface. Data from the Cassini orbiter further proved the existence of entire oceans of methane on Titan. The Cassini-Huygens collaboration also helped scientists to understand the surprising similarities between Titan and Earth. Like Earth, Titan's atmosphere is composed primarily of nitrogen and is perfect for protecting against the sun's radiation. What Titan lacks in oxygen, it makes up for with methane. The moon is drowning in it. Titan's unique cocktail of methane and nitrogen is reminiscent of Earth's back when microbes dominated our planet, more than 3 billion years ago. That means Titan is a sort of time capsule, revealing insights about our distant past. It's a replica of Earth, but from billions of years ago. This makes Titan an ideal place to study Earth's ancient development, as we evolved from single-celled organisms into complex and sentient beings. Scientists are optimistic about finding microbial organisms on Titan and are eager to continue observing the evolution of this very interesting moon. Dragonfly is a collaboration between NASA, the Johns Hopkins Applied Physics Laboratory, APL, and numerous other organizations. It's an $850 million project that will study Titan's organic chemistry, its surface geology, and possible life forms. The mission plans to build on the success of the Cassini-Huygens mission and improve our knowledge of how life on Earth began. Did you know that if you put on a pair of wings and flap your arms hard enough on Titan, you'll fly? With 1/7 of Earth's gravity and 4 times its pressure, Titan is perfect for flying. That's why Dragonfly is being designed as a rotorcraft lander, meaning it is a drone-like spacecraft that will be able to fly and explore autonomously. It's equipped with rotors that will allow it to take off, fly and land in various locations on Titan, providing a unique perspective of the Moon's geology. The rotorcraft is similar in size to many of the Mars rovers, weighing in at about 450 kilograms, 992 pounds. Dragonfly has 4 arms, each of which can support 2 stacked helicopter rotors. Its 8 rotors each measure around 1 meter, 3.3 feet in diameter. On Titan, the aircraft will be able to reach speeds of 36 kilometers, 22 miles per hour, and climb altitudes of up to 4 kilometers, 13,000 feet. Due to Titan's thick clouds and its distance from the Sun, using solar energy to power Dragonfly is out of the question. No sun, no problem. The drone will use a nuclear power source to generate heat that will be converted into energy by a radioisotope thermoelectric generator. The energy will then be stored in lithium batteries that provide the drone with direct power to perform its activities. NASA expects to launch Dragonfly sometime around June of 2027. Too long to wait? Well, to make matters worse, Dragonfly is not expected to parachute its way through Titan's thick clouds until sometime in the mid-2030s. Dragonfly will touch down in Shangri-La, a dune landscape close to Titan's equator. The spacecraft will also go to the Selk impact crater, where a water lake is thought to have been formed by the impact's force. The octocopter will carry a suite of scientific instruments to study various aspects of Titan. These instruments include a mass spectrometer to analyze the composition of Titan's atmosphere and surface, a gamma-ray and neutron spectrometer to investigate the Moon's elemental composition, a meteorology station to measure atmospheric conditions, and a host of cameras to capture high-resolution images of the Moon's surface. Seasons on Titan last a lengthy 7.5 years, and it takes 16 Earth days to equal 1 Titan day. This means Dragonfly will make trips to select locations on the Moon only once every 16 Earth days, in spurts lasting 30 minutes each. If Dragonfly isn't reliant on solar power, why does the day-night cycle on Titan affect when it flies? For starters, let's not forget Titan is still an icy moon, and at nighttime it gets really cold. If Dragonfly were to work in such conditions, the performance and efficiency of its systems would suffer. There's also the visibility problem. Nighttime is lights out on all of Titan, and any attempt to operate the drone with little to no visibility could prove costly to the mission. Better safe than sorry. Dragonfly will explore diverse regions of Titan, including its methane lakes, dunes, and impact craters. Detailed imaging and geological investigations may also unveil unique geological formations, such as cryovolcanoes or icy structures shaped by Titan's weather patterns. Titan's organic-rich environment, coupled with the presence of liquid methane and ethane, makes it an intriguing candidate for habitability. Its findings may provide clues about the conditions necessary for life to emerge and survive on a moon like Titan. Already, Dragonfly is being tested in Titan-like environments here on Earth. Using the Transonic Dynamics Tunnel, TDT, at the Langley Research Center, engineers recreated Titan's atmosphere and tested Dragonfly within the tunnel. As a failsafe, they also tested the drone's ability to perform activities with a faulty set of rotors. Thanks to these tests, the team confirmed that Dragonfly will be able to operate even if a malfunction occurs in one of its rotors. As perfect as Dragonfly seems for exploring Titan, it does suffer one major drawback. The octocopter cannot explore the deep methane oceans that make Titan stand out from all the other moons in our solar system. So how do we explore a deep methane ocean on a distant moon? The current idea is in the form of a submarine. No, they're not calling it the Titanic. The concept for a Titan submarine involves a robotic watercraft equipped with the ability to navigate and explore the methane seas of Titan, autonomously. The submarine would be designed to withstand extremely cold temperatures and operate in a hydrocarbon-rich environment. It would carry scientific instruments to analyze the composition of the seas, map the topography of the seabed, and study any potential organic or biological activity. The Titan submarine is still just a concept, but the plan is to have it explore Titan's largest northern sea, the Kraken Mare. NASA has already begun funding the project, but who knows when we'll get to see an actual prototype. Real progress is not expected to be made until after a surface mission by Dragonfly. Still, it is quite staggering to imagine a submarine coasting beneath Titan's methane seas, searching for life. What excites you most about the exploration of Titan? Let us know in the comments.